Welcome back to this lecture series on deep learning. In this lecture, we'll briefly discuss about the topic estimators in machine learning. First, we should know what is estimator. What is estimator in the machine learning? An estimator is a mathematical function. It is a mathematical function that estimates unknown parameters using observed data, and it is used to learn from data in both regression and classification models. In machine learning, estimator, the purpose of using estimator is it is used to help and adjust the model parameters during training. And let us take this example. If the given data set is consists of x1, x2, x3 up to xm, and an estimator data cap is given by g of x1 bar, that is x1, x2 up to function of, that g means the function of x1, x2 up to x of m, where theta cap is the estimated value of unknown parameter theta. This is unknown parameters. If you are taking theta, this is theta cap is the estimated value. Next, introduction. So in machine learning, how the estimator is used, that we'll see first. In machine learning, an estimator refers to the any method or rule used to approximate an unknown quantity, mainly unknown quantity we are going to measure, or parameter based on observed data. For instance, if we don't know the true mean of a population, we can use the sample mean of an estimator. And estimators allow us to generalize from a small sample to the broader population. This is essential because we often cannot measure or observe the entire population, especially in large scale data applications. They form the estimators, form the foundation for training models in both supervised learning, the like regression on the classification, and unsupervised learning like clustering. Estimators are used to learn weights, identify patterns, or infer hidden variables. In a simple term, an estimator is a mathematical formula or algorithm that uses the data to produce a guess about some unknown quantity. It does not just give the result of it does not just give a result. It provides a way to calculate it from a sample data. Next, the types of estimators. A point estimator gives, here there are various types are there: point estimators, interval estimators, and function estimators. First one is the point estimator. A point estimator gives a single number, single value or single number as an estimate of an unknown parameter. For example, using the same average to estimate the population average is the point estimate. These are commonly used when one needs a quick or a specific prediction. An interval estimator, if you are taking, on the other hand, gives the range within which the unknown parameter is likely to lie in that case. For example, we might say the population mean lies between 45 and percentage, 45 and 55 within 95 confidence interval. This accounts for uncertainty function estimators. And next, this also, if it is expressed within the confidence level. So if a 95% means, we can say it as we might say population mean lies between 45 and 55 with the 95 percentage confidence. This accounts for uncertainty. Next, function estimators are used when the goal is not just to estimate a value but a whole function, like in regression model. For instance, estimating the function, suppose if you are writing w0 plus w1 x1, like that, W naught, W1, X1, and W2, X2. It is done using the training data in the linear regression. So, what are all the three types? Function estimators, interval estimators, and function estimators. Based on the application, we are going to choose the estimators. So, say for example, the point estimators, if you are taking, let us consider a simple and a common point estimator, the sample mean. Here, see here, this is here summation should come. Yeah, I have the data x1, x2 up to xn. Further, suppose we have a data set of values such as student heights or product prices. The same mean is calculated by adding all the values. How we are going to find out the mean for this x1 plus x2 plus x3 divided by n? How many numbers are? This is the total numbers dividing by the number of items. So the formula is given by, this is the mean estimator, mu cap is given by 1 by n summation 1 to n into x1 x2 x2 up to xn. This I varies from 1 to n. So the point estimators are widely used in machine learning to estimate values such as weights in model or a probability of a class label. In each case, estimator generates a single best guesses based on the training data. So linear regression, it is used to estimate the weight. Navies based is to probability probabilities, and decision trees are used to estimate the impurity values. Next, properties of a good estimator. As estimator is unbiased if on average it correctly estimates the true parameters. In mathematical term, this means the expressed value of estimator equals the actual parameter value. For example, the sample mean is an unbiased estimator of the population mean. An estimator is consistent if it becomes more accurate as more data is added. That means unbiased. An estimator is consistent if it becomes more accurate as more data is added. That means with large enough samples, the estimate gets closer to the true value. This is a desirable property because it means that collecting more data will improve over that is our estimates. And efficiency refers to consistency. Second one, this efficiency refers to the estimator having the smallest possible, small that is lowest possible variance among all unbiased estimators. That means it fluctuates less from sample to sample and gives a stable result. Next, sufficiency. The sufficient estimator captures all relevant, all the information in the sample that is needed to estimate the parameter. This means it uses a data in the most informative way possible without losing any detail relevant to the parameter of interest. Next, function estimator. If you are taking the example, a function estimator attempts to estimate an entire function that maps inputs. That is feature. Inputs means what? Inputs means a feature. So all the features it will be going to consider. And to outputs, maps inputs to outputs. Outputs we are calling it as how labels. Labels or predictions, we can say. For example, in predicting house prices based on square footage, the function might be f of x. Function might be the f of x. We can write it as w naught plus w1 x1 or w1 f of x or w naught w1 x1 w2 x2 etc. The underlying model assumes that some noises in the data is present. This is the noises in here. Usually the functions we can write it as w1 w1 x1 and etc, and some noises are present. This may also be added. Here the epsilon is the noise. Here the y is what? What is the y? Y is the observed output. F of x is the true function and epsilon is the error or noise in the observation. In linear regression model, the function is modeled linearly. F cap of x equal to w naught plus w1x. If we estimate the weight W0 and W1 using training data, which is an example of using estimator to fit the functions. So it in a tool like sklearn, estimators are objects that implement a fit method, which may mean the learn from the parameters or from the data. For instance, linear regression, it uses the input x and output y to estimate the weight of a linear model. Next, if you are taking the comparison table between estimator versus model versus classifier, an estimator in the machine learning, here first case, estimator in the machine learning in any process or function that calculates an estimate of a parameter or relationship based on data. For instance, using maximum likelihood to estimate the probability of a class label in an estimator. Next, model refers to what it will do is in the model refers to a mathematical structure. It will refers to the mathematical structure that defines how input data is related to output data. This includes both the structures like a linear or a, here in this case, a linear or a tree based, linear or a tree based data we are going to consider in this case, and the learned parameters. A trained model is ready for the prediction. Next term, if you are taking classifier in machine learning, how it has been used is a special type of model or estimator, special type of model or estimator used in classification problems. It predicts categories or labels such as whether an email is spam or not. Examples include logistic regression, decision trees, and sub SVMs, decision trees, DT, and logistic regression, and SVMs or the classifiers. And the examples, if you are taking here, the sample mean regression for weight, and here the SVM logistic regression and the neural network decision tree. So to summarize, all the classifiers are models that use an estimators to learn parameters. Estimators are the core building blocks that helps train machine learning models from the data. So hope everyone understood about estimators. The remaining things we'll discuss in the next lecture. Thank you.